Okay, today in class we worked on how to divide fractions by fractions using a visual model and also the multiplication method. So let's start with looking at things through the visual model. So if I have my problem 7/8 divided by 3/8, I'm going to start with my 7/8 here, and that's going to be the total amount. I'm going to have to split that into parts or groups of 3/8. So I would draw a picture that is going to have 8 boxes because I'm dealing with eighths as my denominator. So I'm going to just split this in half to make 2. If I split both my halves into halves, I make 4. Then if I split each of those from there, I can make 8. So here I have my 8 boxes. I'm going to color in 7 of them to illustrate my 7/8. So here's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, and finally 7/8. So I have 7 out of 8 boxes. Now, when I divide this into groups of 3/8, that means I need 3 pieces in a group each. So if I count this out, I have 1, 2, 3. These 3 together are going to make one group of 3/8 because I have 3 out of the 8 boxes. And each of these is worth 1/8 each. 1/8, 1/8, 1/8, and I need 3/8. 3 of them make one group. I now need to make another group of 3. So I'm going to count again 1, 2, 3. These 3 together make a second group of 3/8. When I look, I have this one left by itself. I don't have enough to make a third group of 8. I do just have 1 left. So that's going to be the numerator in my mixed number answer here. But when I think about this, I have 1. But how many did I want in a group? Well, when I look back at my other problems, every single time I was putting 3 in a group. So I have 1, but I needed a group of 3, so that would be I have 1/3 of that left. So I have 2 whole groups to get my answer of 2, and then I have 1 left over, but I needed a group of 3. So my answer would be 2 and 1/3. Now, I can also do this with a multiplication model as well. So let me go to a new slide here, and if I say again to have the problem 7/8 divided by 3/8. What we've seen in all of our work in our previous lessons is that I can always keep my first fraction the same and my second fraction I'm flipping, which is something actually called the reciprocal. So I would take my numerator and denominator and just flip them over, and the reciprocal would be 8/3. I now can multiply my fractions together. 7 times 8 is 56, and 3 times 8 is 24. From here, this is an answer that I can now work on simplifying. So what I'm going to do is I'm going to look at 56 and 24 and think, okay, what goes into both numbers? Well, they're both even, so I know that 2 can go into both of them. But I feel like another number can go into more of them. So I think through all my multiplication facts, I know that 56 can be divided by 8, and 24 can also be divided by 8. So I'm going to divide both of them by 8. 56 divided by 8 is 7. 24 divided by 8 is 3. You'll notice I now have a simplified answer, but my answer is an improper fraction. So hopefully you remember from last year how to turn my improper fractions into mixed numbers. This line in the middle here, it still is a division problem. I don't want to just pick up my calculator though, because my calculator is going to give me a decimal answer, and I want a fraction answer because this is a fraction problem. So I can pick up do my long division on my paper. 7 is my dividend, so it goes inside, and 3 is my divisor, so it goes outside. How many times can 3 fit into 7? 2 times. 3 times 2 is 6, so I have 1 left over. So when I look at this on here, somebody showed me the strategy you guys learned from last year that some teachers taught that you can do this as a check mark. So I start at the top, 2, 1/3. I can kind of make the check mark to connect them together to get an answer that 7/3 is the same as 2 and 1/3. So no matter if I did the multiplication method or if I did my model method, I get 2 and 1/3 as long as I'm simplifying my answers. So there's dividing fractions by fractions using visual and multiplication.